This code imports several libraries such as NumPy, Pandas, Math, Sklearn, Datetime, OS, Matplotlib.pyplot, and TensorFlow. These libraries are commonly used for scientific computing, data analysis, machine learning, and plotting. The code then sets the percentages for the size of the validation and test datasets to 10%. This means that the remaining 80% of the data will be used for training. Next, the code displays the parent directory and the working directory, along with their respective contents. The parent directory is obtained using the os.path.dirname, os.getCode function, and the contents of the parent directory are listed using os.lister, os.path.dirname, os.getCode. Similarly, the working directory is obtained using os.getCode, and its contents are listed using os.lister, os.getCode. This code is used to get an overview of the directories and files within the directories to ensure that the correct data is being accessed. It is often used as a debugging tool to verify file paths and check the organization of the data. Is accessing the attribute shape of the variable y_train. Y_train is likely a variable that represents the training labels or target values in a machine learning model. The shape attribute is a property of NumPy arrays in Python, and it returns a tuple that represents the dimensions of the array. In this case, y_train.shape returns a tuple that specifies the size of each dimension of y_train. For example, if y_train is a 1D array with 100 elements, the shape would be 100. If y_train is a 2D array with 100 rows and 50 columns, the shape would be 150. By accessing the shape attribute, this code allows us to get information about the dimensions and size of the y_train array. Code is visualizing the predicted and actual stock prices. The first part is creating a figure with two subplots. In the first subplot, it plots the train, validation, and test target values as well as the predicted values. The train target values are plotted in blue, the validation target values in gray, and the test target values in black. The train prediction values are plotted in red, the validation prediction values in orange, and the test prediction values in green. The title of this subplot is Past and Future Stock Prices, and the x-axis represents time in days while the y-axis represents normalized prices. A legend is also added to the plot to distinguish between the different lines. The second subplot only shows the test target and prediction values. The title of this subplot is Future Stock Prices, and the x-axis and y-axis have the same meanings as in the first subplot. Again, a legend is added to the plot. After plotting the stock prices, the code calculates the correct sign prediction for the close, open price for the train, validation, and test sets. This is done by comparing the signs of the differences between the closing and opening prices of the target and predicted values. If the signs are equal, it is considered a correct prediction. The results are then printed, showing the percentage of correct sign predictions for the train, validation, and test sets. Analyzing a dataset of stock prices by importing it and performing some initial data exploration. Here is a step-by-step breakdown. 1. The code first imports the stock price dataset using the pd_read_csv function from the pandas library. The dataset is assumed to be stored in a file named pricessplit_adjusted.csv located in a directory /input. 2. The imported dataset is then assigned to a variable called df, indicating that it is a dataframe object. 3. The df.info function is called to provide some information about the dataset. This includes the number of rows and columns in the data frame, the data types of each column, and the memory usage. 4. The df.head function is called to display the first few rows of the data frame, giving a visual preview of the data. 5. The list, set, df.symbol expression is used to create a unique set of values from the symbol column of the data frame. This column presumably contains the stock symbols. 6. The length of the unique set of stock symbols is printed using len, list, set, df.symbol. This gives the number of different stocks included in the dataset. 7. Finally, the first 10 elements of the unique set of stock symbols are printed using print, list, set, df.symbol, 10. This provides a sample of the distinct stock symbols present in the dataset. Code df.tail is used to display the last 5 rows of a dataframe df. A data frame is a two-dimensional labeled data structure with columns of potentially different types, example numerical, string, boolean, etc. It is a widely used data structure in pandas, a popular data analysis library in Python. The tail method in pandas is used to return the last n rows of a data frame. By default, n is set to 5, so df.tail returns the last 5 rows of the data frame df. This is particularly useful to quickly inspect the end of a data frame, especially when working with large datasets. It allows you to verify how data is structured and check for any patterns or issues that may be present in the dataset. Describe is used to generate descriptive statistics of a data frame or a specific columns within it, depending on how the data frame is structured. When called, the describe function provides summary statistics such as count, mean, standard deviation, minimum, maximum, and quartiles for numerical columns in the data frame. These statistics provide valuable insights into the distribution, central tendency, and variability of the data. The output of df.describe includes the following statistics for each numerical column: count, the number of non-missing values in the column; mean, the average value of the column; STD, the standard deviation, which measures the spread or dispersion of the values in the column; min, the minimum value in the column; 25%, the first quartile, which represents the value below which 25% of the data falls; 50%, the second quartile, median, representing the value below which 50% of the data falls; 75%, the third quartile, representing the value below which 75% of the data falls; max, the maximum value in the column. The describe function can also be used to generate summary statistics for non-numerical columns, such as the count, unique values, the most frequent value, and the number of occurrences of the most frequent value. Overall, df.describe is a useful tool for quickly understanding the basic statistical properties of a data frame or specific columns within it, helping to identify outliers, assess data quality, and gain insights into the data distribution. Code df.info is used to display a summary of information about a pandas data frame object df. By calling this method, you can get an overview of the data frame's structure and contents. The output of df.info includes the total number of rows and columns in the data frame, the names of each column and their respective data types, the count of non-null values for each column, the amount of memory used by the data frame. This information is useful for understanding the general characteristics of the data frame, including the presence of missing values and the types of data stored in each column. This code is plotting a figure with two subplots using the matplotlib library. The first subplot, located at position 1, 2, 1, displays the stock price of a company with the symbol EQX. Specifically, the code retrieves the open, close, low, and high values for the EQX symbol from a data frame called df and plots them using different color lines. The open values are plotted in red, close values in green, low values in blue, and high values in black. The title of the subplot is set as stock price, the x-axis is labeled as time, days, and the y-axis is labeled as price. A legend is also added to the plot to indicate which color corresponds to which line, and it is set to be placed in the best location. The second subplot, located at position 1, 2, 2, displays the stock volume of the same company EQX. The code retrieves the volume values from the data frame and plots them in black. The title of this subplot is set as stock volume, and the x-axis and y-axis labels are set similar to the first subplot. A legend is also added to this subplot, placed in the best location. The code does not display the plot immediately as it is commented out with a hashtag in front of the plt.show method. If you remove the hashtag and run the code, it will show both subplots in a single figure. Performs several tasks related to stock data analysis and modeling. 1. The normalize_data function takes a data frame df as input and applies min-max normalization to the open, high, low, and close columns of the data frame. This normalization scales the values of these columns between 0 and 1. The function returns the modified data frame. 2. The load_data function takes two inputs, a stock data frame stock and a sequence length seq_len. It first converts the stock data frame into a numpy array using the as_matrix function. Then, it creates all possible sequences of length seq_len from the stock data. It splits the data into train, validation, and test sets based on the given percentages for each set. Finally, it returns the train, validation, and test sets. 3. The code selects a specific stock from the data frame df using the symbol column. It removes the symbol and volume columns from the selected stock data frame. 4. The calls variable stores a list of column names from the selected stock data frame. 5. The code creates a copy of the selected stock data frame called df_stock_norm. It performs the min-max normalization on this copy using the normalize_data function. 6. The code sets the seek_len variable to 20 and calls the load_data function to create the train, validation, and test sets using the min-max normalized stock data frame df_stock_norm. 7. The code then prints the shapes of the train, validation, and test sets to display their dimensions. Uses the matplotlib library to create a figure with a line plot. The figure size is set to 15 units wide and 5 units tall. 4 lines are plotted on the graph, each represented by different colors and labels. The y values for the lines are taken from the open, close, low, and a height columns of a data frame called df_stock_norm. The title of the graph is set to stock, and the x-axis is labeled as time, days. The y-axis is labeled as normalized price/volume. A legend is added to the graph to indicate the colors and labels of the lines. The legend is positioned at the best location. Finally, the graph is displayed using the plt.show function. Implementing a basic recurrent neural network, RNN, using TensorFlow. It is specifically designed for sequential data and can be used for tasks such as time series prediction or sequence classification. The code begins by shuffling the training data randomly. Then, a function called get_next_batch is defined. This function is responsible for returning the next batch of training data. It keeps track of the current index in the epoch and updates it after each batch. If the end of the training data is reached, the permutation array is shuffled again to create a new random order for the next epoch. Next, the code sets various parameters such as the number of steps, seek_len, 1, number of inputs, number of neurons in each layer, number of outputs, number of layers, learning rate, batch size, and number of epochs. The size of the training and test sets are also determined. After resetting the TensorFlow graph, the code defines placeholder variables for the input data, x, and the target output data, y. The code then creates a list of RNN cells for each layer. In this case, it uses the basic RNN cell, but there are commented out options to use basic LSTM cell with peephole connections, or GRU cell. The number of neurons in each layer is specified. A multi-RNN cell is created by passing the list of RNN cells, which represents the stacked layers of the RNN. The dynamic_RNN function is used to connect the RNN layers to the input data, x, and obtain the RNN outputs and states. The output from the RNN is reshaped into a 2D tensor and passed through a dense layer to produce the final output. The output is then reshaped back into the original shape of the input, keeping only the last output of the sequence. The loss is calculated as the mean squared error between the predicted output and the target output. An atom optimizer is used to minimize this loss. The code then creates a TensorFlow session and initializes all global variables. It trains the RNN by running the training operation in a loop for a specified number of iterations. After each iteration, it evaluates the mean squared error on the training and validation data and prints the results. Finally, it uses the trained RNN to make predictions on the training, validation, and test data and stores the results in the variables y_train_pred, y_valid_pred, and y_test_pred respectively.